The thermodynamic process involved in the propagation of sound wave in gaseous medium is adiabatic, isothermal, isobaric, or isochoric. Now, if you recall the chapter of thermodynamics, we have gone through all these four processes. What is an adiabatic process? Tell me. In adiabatic process, there is no exchange of heat between the system and surroundings, right? That is why we can say del Q is equal to 0. What about isothermal? The temperature remains constant. Temperature is not going to change. So, del T equals to 0. Isobaric. In isobaric process, the pressure is going to remain constant. It is not going to change. That is why del P equals to 0. What about isochoric? There is no change in volume. That is why del V equals to 0. So we have to focus on four parameters: Q, T, P and V. Yes? Alright. Now coming back to sound waves traveling in a medium. Whenever a sound wave is traveling through a medium, we know that there is a formation of compressions and rarefactions. Compressions and rarefactions. What do you mean by that? At the position where there is formation of compression, there is contraction in volume, right? Let's say here's the position where we have compressions. If there is compressions, the molecule come closer. If there is compression, the molecules come closer. And wherever there is rarefaction, the molecules go far from each other. That is why at the point of compressions, there is contraction in volume. At the position of rarefaction, there is expansion of volume. So how can we say that volume is going to remain constant? Volume is changing throughout the medium, right? And that is why del V cannot be equal to 0. There is a change in volume. If there is a change in volume, the process cannot be isochoric. Am I right? Yes. Talking about pressure, we have already seen that whenever a sound wave is traveling through a medium, there is a variation in pressure. And this equation tells us del P is equal to minus del P naught cos kx minus omega t. According to this equation, the pressure is going to vary throughout the medium. So in short, we can say del P cannot be equal to 0. If del P is not equal to 0, that means the process cannot be isobaric. The process cannot be isobaric. So two options sorted. Now talking about T and Q. According to Newton, wherever there is formation of compressions, the temperature of the medium at that point increases. Now when the temperature of the medium increases, the medium exchanges heat from the surroundings. It gives out heat to the surrounding. Let's say at this point we have compression and there is a rise in temperature. So the medium gives out heat to the surrounding and it maintains its temperature at the same level. Now wherever there is formation of rarefactions, the temperature of the medium decreases. If the temperature of the medium decreases, it extracts heat from the surroundings. It extracts heat from the surroundings and maintains its temperature at the same point. So, according to Newton, temperature of the medium remains constant because of the heat exchange from surroundings, right? So, process is isothermal according to Newton. Process is isothermal according to Newton. Now, according to this analysis, according to this theory, Newton tried to calculate the speed of sound in the medium. And when he got a value, he saw that that value which he calculated from his theory and analysis is not matching with the actual speed of sound, with the experimental value of speed of sound. So, this theory was ruled out. Now came another scientist, a mathematician, Laplace. He told that the process of traveling of sound waves in a medium is so fast that the medium doesn't get time to exchange heat with the surroundings. So if the medium is not getting time to exchange the heat, so the temperature is not going to remain constant. The temperature will change. If the temperature will change, the process cannot be isothermal. But along with that, there is no exchange of heat between the system and surroundings. If there is no exchange of heat between system and surroundings, del Q is equal to 0. That means which process? Adiabatic. So according to Laplace, del Q is equal to 0, but del T is not equal to 0. Process is not isothermal, it is adiabatic because the medium is not getting time to exchange the heat from the surroundings. Yes? Now, from his analysis, from his theory, from this process, Laplace calculated the speed of sound and he got a value which was very near to the actual speed of sound. So, theory proved, and whatever his analysis was, that was correct. That was taken as correct because the speed of sound was matching, was agreeing with the experimental value. Right? That is why the corrections made by Laplace was accepted and the process is called as adiabatic. So the process will be adiabatic when the sound wave is traveling through the medium, and that is why option A is the correct answer for this question. The next question is on velocity of sound. And the question says, when the temperature of an ideal gas is increased by 600 Kelvin, the speed of sound in it becomes root 3 times the initial speed. Now the initial temperature of the gas is. What is the formula? What is the concept? What is the equation we can use here? Just figure it out. One equation for velocity. Root over of gamma RT by M. Let me write it again. V is equal to root over of gamma RT by M. Now the question is saying that the whole process is happening under the same gas. Only the temperature is varying, everything else is remaining constant. Correct? Okay. So if everything remains constant, from this equation we can say V is proportional to root over of temperature. Correct? Okay. Now let's figure out what has been given in the question once more. When the temperature of an ideal gas is increased by 600 K. Increased by 600 K. So let's say Ti is initial temperature and Tf is the final temperature. And according to question, Tf is equal to Ti plus 600. Fine? Okay. Now let's say Vi is the initial velocity, Vf is the final velocity, and according to question, Vf is equal to root 3 times Vi. So this is our information given in the question. Okay. Now from equation number 1, we can say Vi by Vf is equal to root over of Ti by Tf. Now in place of Tf, we can write Ti plus 600. Easy to go? Okay. Now in place of Vf, we can write root 3 Vi is equal to root over of Ti by Ti plus 600. Here Vi cancels off. Now from here, if you calculate Ti, what do you get? You will get Ti as 300 Kelvin. And this is what the question is asking us. Easy problem, right? If you remember this formula, easy to go, right? Okay. So the answer is 300 Kelvin. The initial temperature was 300 Kelvin. Now if we see the options, option B is mentioning 300 Kelvin, and that is why it is the correct answer for this question. Maximum sound pressure tolerated by the human ear is 30 newtons per meter square. Now for sound of frequency 10 cube hertz and a speed 300 meters per second, the maximum displacement of particles of medium is, we can take density of air as 1.5 kilograms per meter cube. Now, if you recall the formula, it is P naught is equal to B A naught K. What is P naught? P naught is the maximum amplitude of pressure. What is A naught? A naught is the maximum amplitude of displacement. So basically we have to play around this equation. Correct? Okay. So P naught is equal to B A naught times K. But in question, we have not been given bulk modulus. So how can we replace B in terms of the quantities which have been given in the question? Tell me. Can you remember any formula? Speed is given as root over of bulk modulus by density. And from here, we can say B is equal to V square rho. Let's keep it as 1. Correct? Okay. So let's move further. A naught is equal to P naught by B times K. In place of B, we can write P naught by V square rho. In place of K, we can write 2 pi by lambda. So this is 2 pi by lambda. Lambda, wavelength, not given in the question. So in place of lambda, we can write V by F. So P naught V by V square rho into 2 pi F. Fine till now. Okay. V goes off, and from here, the equation reduces to P naught by V rho into 2 pi F. Now in question, we have been given P naught as 30 newtons per meter square. Frequency as 10 cube hertz. Correct? Speed is 300 meters per second. What else? Density. Density is given as 1.5 kilogram per meter cube. Is there any parameter in the equation which is not given in the question? No. P naught, we have. Velocity, we have. Density, we have. Frequency, we have. Correct? Now, if you place these values in this equation, you will get A naught as 1 by 3 pi into 10 to the power minus 4 meters, and that is our maximum amplitude of displacement. Easy? Okay, let's check the options. Option D is the correct answer for this question. The speed of longitudinal wave is given by V is equal to root over of E by rho, where rho is the density of the medium. Match the following columns for the quantities represented by E in different media. I think this is a memory-based question. Solids, liquids, and gases. If you remember the formula, for solids, V is equal to root over of Young's modulus divided by rho. For liquids, it is V is equal to root over of shear stress by density. And for gases, it is V is equal to bulk modulus by density. Right? So this is basically a memory-based question. So in solids, it is Young's modulus, right? Young's modulus. In case of liquids, it is shear modulus. And in case of gases, it is bulk modulus. So I think this question doesn't need much of analysis, much of calculations. So straight away, we should move to the options, right? Agree? Okay. So for solids, it is Young's modulus. So this is A. For liquid, shear modulus. So this will be B. For gases, it is bulk modulus. This is C, right? So A to R, B to Q, and C to P. That is why option B is the correct answer for this question. Now moving ahead to this question. The speed of sound in hydrogen gas at STP is V naught. The speed of sound in a mixture containing 3 parts of hydrogen gas and 2 parts of oxygen gas at STP will be. Now we have our formula. V is equal to root over of gamma RT by M. This is the equation, correct? Now, In our question, we have two cases. First, second. First case, we have hydrogen gas. In second case, we have a mixture of hydrogen and oxygen gas. All right. The question is saying that in both the cases, the process is happening at STP, standard temperature and pressure. That means temperature and pressure are constant for both the cases. Correct? Talking about gamma, in both the cases, we have only diatomic gases. That means gamma will be 7 by 5 for both of them. That means for this question, in both the cases, gamma is same. So we can say gamma is constant for this problem. So what we are left with? V is proportional to root over of 1 by m, where m is our molar mass. Correct? All right. So moving ahead with this equation, V is proportional to 1 by m. Now in case 1, where we have hydrogen gas, the molar mass is 2, right? In second case, we have a mixture of hydrogen and oxygen gases. Number of parts for hydrogen is 3, for oxygen is 2. Let's say this is N1, this is N2. So if you recall from your chemistry subject, the average molar mass for a mixture of gases is given as N1, M1 plus N2, M2 divided by N1 plus N2. Fine? Okay. So N1 is 3 for hydrogen gas and the molar mass is 2 plus N2 is 2 and the molar mass of oxygen is 32 divided by N1 plus N2. N1 is 3, N2 is 2. Fine till now? Yes? Okay. So 3 2s are 6 plus 32 into 2 is 64. So 64 plus 6 is 70. This will be 70 by 5 and this is 14. So the average molar mass for a mixture of 3 parts of hydrogen and 2 parts of oxygen will be 14. So let's write it separately. Let's erase all this. 14. Right? You can write AMU in front of it if you require. Okay. So V1 by V2 is equal to root over of M2 by M1. M2 is 14. M1 is 2. Correct? Okay. 2 7s are 14 and finally V2 is equal to V1 by root 7 and in question V1 is given as V0, so this will be V0 by root 7. So what is our answer? The speed in the mixture of these two gases will be V0 by root 7. Easy? Okay. So moving on to the options. Option D is the correct answer for this question.